Hello everyone, welcome back to my YouTube channel. My name is Ray. Have you ever gotten a chemistry question wrong, not because your math was incorrect, but because your rounding was wrong? That's significant figures, and today I'm going to make them so simple that you'll never lose points on them ever again. I'm going to start off by explaining what a significant figure is. Significant figures are the digits in a number that carry meaning about its precision. So in chemistry, we don't just care about the number, we care about how precise that number is. So if we have 12 and 12.0, in chemistry, we're going to prefer the 12.0 because it tells us the measurement was more precise. Note, 12 and 12.0 are not the same. And we're going to understand that now by going over the rules of significant figures. So the first rule states that all non-zero digits are significant. Non-zeros are exactly what they sound like. Everything that's not a zero, so a 1, 2, 3, 4, 5, etc. Here we have 8, 3, and 2. All of these are non-zero, and we have 3 of them. So this is going to be 3 significant figures. Here we have 6, 4, 6, 7. We have 4 non-zeros, so there are going to be 4 sig figs. Perfect. Rule 2 states that interior zeros, or the zeros that are between two numbers, are also significant. So not only are non-zero significant, but also the zeros between them. Here we have 2 non-zeros, 8 and 7, and then 1 zero that's sandwiched between the two of them. So here we're going to have 3 significant figures. Here in this other number, we have 1, 2, 3, 4 non-zeros, and then 2 zeros squished between them. So we're going to have a total of 6 sig figures, significant figures. Now, rule number 3 states that trailing zeros, or the zeros that fall behind, that fall after a decimal point and behind a non-zero are significant. An example of that would be 6.20. The 0 is not only behind a decimal point, but it's also behind a 2, which is a non-zero. Therefore, it is considered significant. So here in 6.20, we have 3 sig figs. What about 45.00? In 45.00, we have 2 zeros that are not only behind a decimal point, but also behind a non-zero. So we're going to have a total of 4 sig figs. Rule number 4 states that trailing zeros that fall before the decimal point and are behind a non-zero are significant. So that would be these zeros right here that are before the decimal point, but that are behind a non-zero. That means that we're going to have 1, 2, 3, 4 sig figs. Why sig figs? Why 4? Well, because we're applying rule number 1, 4 is a non-zero. We are applying rule number 3, that every trailing zero that falls after a decimal point and behind a non-zero is significant. And we're applying rule number 4, which states that the trailing zeros before the decimal point and behind a non-zero are significant. So here we also have 4 significant figures. Let's look at rule number 5. Rule number 5 states that leading zeros are not significant. Leading zeros are the zeros that go in front of a non-zero. These leading zeros are not significant, so they do not matter. So we ignore them, and we're only left with 1 significant figure, which is 4. And lastly, rule number 6 states that trailing zeros at the end of a number, but before an implied decimal point, are ambiguous and should be avoided by using scientific notation. This states that any zero that is behind a number, but that is before an implied decimal, and we say implied because there is no decimal telling us, right? There is no decimal point. It's just implied. Is going to be ambiguous, right? And the best way to avoid this ambiguity is by writing it in scientific notation. In scientific notation, this would be 8.2 times 10 to the power of what? Well, we need to take this implied decimal point and move it between the 8.2. And that's going to be 1, 2, 3, 4. 8.2 times 10 to the power of 4, because we moved our decimal point 4 times. And these are the significant figure rules. Make sure you understand how they work before you watch my video on how to multiply, divide, add, and subtract while keeping significant figures in mind. So these are the rules on how to These are all the rules you need to know to understand significant figures. Make sure that you have watched this video and understood everything before you watch my other video on how to add, subtract, multiply, and divide while keeping significant figures in mind. As always, if you have any questions, please leave them in the comments, and I will be very happy to help you. I'll see you next time.